Hey everyone, so this is sort of a video series which I'm preparing in which I'll try to speed run through different sections in this sheet, and I'll give you solutions, my thinking process, how I am approaching that solution, and I won't be taking extra tries with this. So this will be one short, like the video might be split into different shorts, but that will be like how I'm approaching it. If I'm making errors, that will be in front of you. So let's get started. The first question is sort an array of zeros, ones, and twos. So I have already opened up here, and see the simple algo won't go to Xcali for this one. Simple algo, if the current element is equals to 0, then we swap start and mid, and we increase mid. Actually, I'll write the code, and this is basically a Dutch national flag theorem. I remember it, but it's like you make start as 0, you make mid as 0, or I can just open Xcali. Let me just do Xcali draw and let me show you. So this is the test case just for you guys. This is the test case. The algo can be, you start from here, this can be your start, this can be your mid, and then this can be your high. And then simple algo, if the current mid equals to 0, you swap mid and start. Mid equals to 1, you do mid plus plus. Mid equals to 2, you do swap of mid and high, and you do high minus minus. Simple algo. And with swap you do start plus plus and mid plus plus. That's it. If I do a dry run, basically you swap mid is 2, basically swap this with this, and you do high minus minus, which will make high come up here. And then you do mid is again 0, so you increase it 1, you increase start 1 as well. Again 0, you increase mid, you increase start. Now you swap it with this, so you swap it, here is 2 and here is 1, and if this particular element is 1, okay, you make high minus also as per the algo. Now since I'm here, I move mid here and then I move mid here, because at 1 we increase mid by 1, and when mid is greater than high, that's where we end. So this is the simple algo. We get a sorted array, and that's it. Let me write the code. Split nums size -1 while mid is less than equal to high. What we do is, and if nums of mid 0, we swap nums of mid and nums of start plus plus mid plus plus. Else if nums of mid equals to 1, we do mid plus plus. Else we do swap of nums of mid and nums of high, and we do high minus minus. That's it. Let's submit it, and there we go. Question done. Hey everyone, so last video we did the first question. Let's start with the second one. Replace and repeated values. Okay, so we are given an index array which contains 1 to n square elements, and each integer appears exactly once except a, and b is missing. So basically b is replaced by a. So we need to find these missing numbers a and b. Okay, so the way I see this is basically, let's take this array. Two ways. First of all, the overall complexity, or basically the size constraints, are 2 to 50. So basically this is here. 50 cross 50 is going to be 2500, which is within our memory limit. So this is within our memory limit. So one thing that we can do is create a vector array and store each element, and then just traverse again and just see if that element is present or not, or twice or not, whatever. Right, that's one thing that you can do. map set, everything else is there. But I think the cleanest thing which I can think of is just creating a memory vector, because even if in map I try to store it, then also it's gonna be that we can't sort it because obviously it's a 2D, so we'll have to convert it into 1D or something. I think the best thing is if we just go ahead and, yeah, if we just create a vector which is int, and I'll name it dp, and this can be grid.size, close grid.size, because it's gonna be 1 to n square, so it's 1 to n square, and since it is inclusive, I'll just increase it by 1, and 0th element won't be there, so here. Now I have to just traverse between the grid dot size I plus plus for in j equals to 0, j less than grid of 0 dot size, and then j plus plus. Yeah, and then let me just do grid of I and j plus plus. So now this is first traversal, which is on square, because we are traversing the grid. But now that does not count because on square is supposed to be there, since we'll anyway have to traverse the grid. Now we have to find out which value is present and which is not. So we just need to see the value across these elements. First we have to give it a, which is appearing twice, and b is missing, and we have to give it missing number a and b like this. Yep, so we'll come up here and we can start by, for in I equals to 1, I less than equal to n cross n, and n is not defined. Let me just define it. I should have defined this way sooner, but anyways, and just a vector answer array, answer dot push back I, and this has to be if dp of I equals to 2. Then we do this. Actually, I can just make the size as 2, because we always want to keep the first element as I. The dp of 0 is I, and we do if dp of I equals to 0, then we just do answer of 1 equals to I, and then over here we just return answer, and there we go. Yep, both cases work, and that is how I would solve it. Let's go on to the third question, merge to sorted array without extra space. Okay, you're given two array, number 1, number 2, and in non-decreasing order, integer m and n representing the number of elements in nums. See, it's simple thing that you have two array. I'll just go over here. You have two array, right? How about, see, merge sort? In merge sort, we try to merge two arrays. We have, oh, everyone has done that question. In this, in merge sort, the array starts from the beginning, right? How about we keep the end pointer for this here, and we keep the end pointer for this here, and we keep the pointer where we are going to store the element here. So how about this is going to be the pointer element, and we create our normal merge logic by like from this. So if 6 is greater than 3, so we put 6 here, and we move this here, and we compare y is end here. We move end here and start here, right? And then we compare 5 and 3. Again, 5 is greater, so we put 5 here and put it here, and then 3 we put here. So it is guaranteed that your nums, this pointer will always point to that element which is currently be which has to be checked, right? So simple. Int end can be nums of 1 dot size. Int f end can be nums, can be m minus 1, I guess, since it has m element in f first end. Second end can be n minus 1, while Fend is greater than equal to 0, and then second end is greater than equal to 0. In that case, we'll do if nums of one of first end is less than or equal to nums of 2 of second end. So if second end is greater or equal to the first one, in that case, we do basically the end element. So the nums1 end element will be nums2 second end. So don't read it as send, I guess. Bad naming on from my side. So else we just do nums1 of end is equals to nums 1 of f end. So we do f end minus minus in this case, and we do s end minus minus in this case. We do end minus minus in every case. That's how we go. And while s end is greater than equal to 0, in that case we do nums of 1 dot end equals to nums of 2 of end, not sound, and then we do n minus minus and minus minus, and we don't have to do fend again, because if only fend is remaining, then in that case that's fine, we can just return it. Let's try running it. Let's see if it works or not. Oh, there's some runtime error, nums1 of end. Well, send is greater than 1 second. Let's do end also. I don't know where this will work, but okay. Weird. This should be this. I think I made some sort of blunder. Yeah, my bad. I had to do this minus one. My bad. Anyways, the question is done. Let's go to the next question, which would be Kadane's algorithm. Now, this is an important algorithm because this, I don't know, like other questions you can, this can be useful there. Let's practice it here. Let me just log in quickly. Yep, there we go. So maximum subarray, simple algo. You're given a subarray. We start it from a pointer which points up here. We keep a total sum which is 0 initially. We keep a current sum which is also 0 initially. At any case, like the whole algorithm is about, if at any case, if current sum is less than 0, we just make current sum as 0. The algorithm is all about this. It at any point, if the current sum gets less than 0, we make the current sum 0. That's it. And after every iteration, we do like total sum equals to max of total sum and current sum, right? So that's the whole algo. Just remember this part. That's it. So if I write it, this is less than 0. I'm pretty sure it's gonna fail for one condition. I'll give the test case myself. I might not have handled all negative cases. Let me just do -1, -2, and then -3, and then -1. Because I think this I can just do int min. Let me try this. Because I'm starting it from 0, which is not right. Yeah, that is wrong. Like my output is 0. It should be max element of array dot begin array dot end. How about I do this? Still, this will make it 0. So how about I make it array of I? Array of I, if it is less than 0, in that case, I make it array of I, and I remove this. I put this inside an else block over here. Let's try out this one. Yeah, this works. Let me compile with the custom test case that we had. Come on, give me the old test case, brother. Ah, damn it. It's not giving me the old test case. Now give me my output. Okay, works. Let's see if it works or not. If not, we'll change something. Yep. Okay. Current sum equals to current sum plus array of I. If current sum is less than 0, current sum equals to 0. If max sum equals to 0, give the max element and make like this. Take this and I'll just put this here. Put this here, or I'll return max sum. Custom input. Answer was 97, right? And I was giving 96. Yeah, now it is right. Who knows? Yeah, it works now. The complication is only when there is a negative number. So max sum becomes 0 in that case. We just have to handle that case. Basically, if all the numbers are negative, we get the current sum as 0 at some place. And there, how about I try one more thing because I just want to. How about I do this array of I just so that. Yeah, this fails, right? Okay, there might be a better way, but somehow this works. Merge overlapping sequence. Let's do this one. Let's see how this goes. Okay, so there are certain intervals we have to merge the overlapping ones. So let's say these are the intervals. We can start from 1, then we go to 3. After 3 there is clearly a gap. So sorry, there's no gap because this 2 comes over here. So if I write 2 over here, 6 ends here, and then 8 will start from here, go till 10, and then 15 and 18. So basically these two sequences are getting merged. We can do a simple greedy algorithm in which we can see if the next start, which is this one, if the next start is greater than the previous, is less than the previous finish, then we change the next finish or we don't. I'll tell you how it works. So basically, first of all, we'll have to sort the whole array down. So for sorting, I'll create another function which will be bool compare, and this will be vector int a and then vector int b, and then return, wait, if a dot 0, actually, yeah, if a dot 0 equals to b dot 0, then we return um a of 1 less than b of 1, right? Otherwise we just return a of 1 or a of 0 less than b of 0. Simple as that. So we sort the intervals dot begin, intervals dot end, and we just give it the compare function inside it. Now we do start initial as, we give the start initial as -1 and initial as -1, or I could have just given it the first one. Let's do and I'll just take int n equals to interval so size over here till I less than n and I plus plus, if start initial equals to -1 and initial in both the cases we'll do start initial as 0. Right. If this is not the case, we'll check if current end is, if, oh sorry, not current end. So if the next starting element is less than the end of initial, then we do and initial equals to intervals I of 1. Right, we'll do this for every n, and if this is not the case, then we'll just do answer. We'll have to create an answer vector int answer, do your answer dot push back start initial and initial. Let's go. Okay. This won't be end initial. This will be wait. This will be when starting is in the next one. 1 second. This one is nice. This is end initial becomes interval. Start is greater. So 1 4 2 3. So we sort it out, and 1 of 4 would be 1 and 2 and 3 and 4. So 3 is less than the end of this. Oh, I need to do max. Initial. Because that is a completely overlapping sequence. So the best thing that Geeks for Geeks does not do and lead code does is adding this use test case button over here. Yeah, this works now. So simple case, I hope you guys got it by just looking at it. Find duplicate in n+1 integer, gonna be the last question in this list. Alrighty, so simple way to do it. The range is 1 to n, right? We need to find the number that is coming twice. What we can do is pick up this number and see, simple thing. In linked list, there's a concept of slow pointer and fast pointer. So you start 2 pointer from here. This one is bigger one, so this is fast, this is slow. So whatever number is here, so basically the nums array contains n+1 integer. This is an important thing. It contains n+1 integer, and each integer is in range 1 to n. So there is only one repeated number nums. So basically 1 to n it will go. So basically if there are 5 numbers in this list, if there are 5 numbers, so the maximum number will be 4. So we can consider 4 as the index of current element. So this 4, if we consider 4 index, so the index will be 0, 1 2 3 4. So 4 will come up to be here, right? So what we can do is we can treat one as fast pointer but one as slow pointer, and then just go to the indices. We start from the 0th, it goes to 1, and then it goes to 3. 3 is here. This goes to over here. Then this goes to 2, which will be like here, and then this goes to 4, which will be like here, right? Now this goes to 2. This goes to 2 again. This comes back here. So we have a loop here, right? The next one for this one will be 4. Now this goes to 4. This comes back to 2. This will come back to, where's that gone? 1 second. It will come back to here. Now both pointers are here. That means there's a loop. So we have a repeating element. Now to find the repeating element, there's a simple algorithm that the distance of this pointer from start to starting of loop, which is here, that will be same as the size of loop. So the size of loop will be 1 2, right? So 1 2, the size of loop is 2, and the distance of this pointer from here to the start of the loop is also same. So what we can do is we can run this element to go one pointer next, and then we can just move this pointer as well in the similar fashion. Wherever these two things meet, that's our interception or something. So I'll write the code. You'll know this is very closely related to linked lists to fast and slow pointer or something. So you can do that. Int fast will be nums of 0, and slow equals to nums of 0. Then while fast is not equal to slow, equals to nums of fast, and then slow equals to nums of slow. And I'll actually move this up here, and I'll remove this, and I'll do here, and then there we go. Yeah, do while loop is better in this because at the start both are same. So once it is there, so flow equals to, actually makes flow equals to nums of 0. So while fast is not equal to slow, move both one step this time. So slow equals to nums of slow, and then fast equals to nums of fast, and then wherever they meet, return the slow. That's gonna be the answer. And there we go. Simple algo. I am sure that we didn't think it this way, but yeah, that saves a lot of memory and all. Because over here, I think in linear time complexity, this is a linear time complexity. So there we go. We have successfully solved the first section of it. That's it for this video. I'll create another one for the next section and then so on. We'll try to solve all of them almost. So in this speed run sort of fashion. So we'll keep on posting them. If you like the video, please do comment. Let me know if you want more of these type of videos in which I do a little bit of explanation, write down the code or something. If you want to code along with me or something, just let me know. Okay.